In this lesson, we'll learn how to make our fueling line dynamic. So this is going to be really neat. Let's go ahead and get started by first turning off auto key. We'll go to our IK tag, and let's go ahead and move to the Dynamics tab and lock this panel down. So here's where it all happens. We'll enable Dynamics. You can see initially the result is pretty harsh, but we'll make this look good in no time at all. Now what I'd like to do first is to define colliders, surfaces that our chain should interact with. We do not want it to intersect through our platform nor the station bench, so let's go ahead and use those as colliders. We'll enable collisions, and we'll then go ahead and expand our landing platform group and grab the platform base as well as the station bench. Alright, great. So now we have properties we can use to control how the chain will interact with its colliders. Notice we have friction. As we start to increase this, that will cause our hose to stay stuck to our collision surfaces. So we might want to increase this just slightly to about 15%. That way we get a little bit of sliding, but still a little bit of pull. We have a bounce parameter to control how the chain will bounce when it hits a collider. Given the material the hose is made out of, it might be best to zero out the bounce. We don't want much of that at all. And then the radius will allow us to prevent interpenetration between our collision surfaces and our dynamic chain. So we might want to increase this just a little bit more so there's more of a proximity between the two objects. Okay, great. So now if we were to start back to our minimum time and hit play, we should notice that our dynamics are starting to look a little bit better, but we still have a few things to fix. So let's go ahead and start back the animation again back to our minimum time and start to adjust our final properties at the top. So notice we have strength, and this controls the chain stiffness. So I might drop this to about 20% so that it's not as stiff, but at the same time we still have a hose that kind of keeps its integrity. And then next we have this drag parameter, and this is very useful if our dynamic chain were to be, let's say, pulled around in a body of water. We can increase the drag to create that type of fluidity. I might increase this just slightly, just to again smooth out the movement of the hose as it comes to a stop, as it falls. Next we have our position hold. This is how well the position of our chain again keeps its integrity. I like to keep this at a high value, but not at the highest, not 100%. Let's say to about a value of 80. That way we can still have the simulation give us a really nice natural look. Now what we would want to drop completely is our rotation hold. This is how well the rotation of each joint keeps its initial state. Now if we bring this up too high, what will happen is that we're going to get a very undesirable look while our joints try to match this current state while still having the dynamic solve take into effect. So I'm just going to go ahead and take the rotation hold here. I'm going to set that to a value of 0. And again, let's go ahead and start back to our minimum time and hit play to take a look at our solve. And you'll notice that we now have a really nice hose animation. Beautiful stuff. So in this lesson, we have learned how to work with Cinema 4D's very robust IK system to have it dynamically fall as the hose separates. In the next lesson, we're going to get right into camera animation.